Okay, so slot 1 we talk about what is matter and so on. So we see what is the important points in this slot. Okay, so I ask you to try out all the page from page 1 to page 30. Okay, so now you can check. Okay, use your red pen to check, and then I will inform you when to pass up your SEEP module for me to check now. Okay, make sure that it is completed. Okay, so now first one, okay, matter. Okay, so there are two criteria for the matter. Something that has mass and occupy space. Okay, so these are the two criteria for the matter. Occupy space, then it has mass. Okay, example of matter here only give you some example only. It's actually more than that. Okay, example of metal like sodium chloride, water, carbon, okay, carbon dioxide, oxygen, etc. Okay. Now, matter also can exist in the forms of elements or compound. Okay, so can be elements, can be compound. So next, okay. So what is elements? So elements is a substance that consists of only one type of atom. So this is element. Then how about the compound? Compound is a substance that consists of two or more atoms with different elements. Okay, they are chemically bonded. Chemically bonded. Okay, example like carbon dioxide, different types of elements. Okay, okay, next, number 6. Matter consists of particles that are tiny and discrete. Okay, tiny and discrete means very, very small. Very small. Okay, so next. Now we look into the type of particles. So there are 3 types of particles, which is atom, molecules, and ions. So what is the difference? Atom is the smallest particles, cannot be divided anymore. Okay, molecules is a neutral particles that consists of 2 or more atoms. It can be same or different types of atoms which are chemically bonded together. Okay, chemically bonded together. This bond is called covalent bond. Okay, covalent bond. Okay. Meanwhile, for the ions, ions, it is the positively charged or negatively charged particles. Okay, so we call it ions. So positively charged normally is the metal ions, which is metal ions. Okay, metal ions. Then negatively charged will be non-metal ions. Okay, next, metal group 18 elements, carbon, silicon, example of atoms. Okay, this one for the molecules are non-metal atoms with non-metal atoms. For example, like carbon with oxygen. Okay, so it forms carbon monoxide or carbon dioxide. Example only. So this one is a covalent bonds or molecules. Okay, sharing of electrons. Ions be metal and non-metal. For example, sodium and then chloride ions. So it will form sodium chloride. Okay, so this one is a ionic compound. Okay, they are consist of ions. Okay. So in chapter 5, we are going to see the molecules and ions in details. In details. Okay. So next, okay, complete the following table. Okay. So substance, let's say helium. Okay, helium. Okay, the particles is the atom. Okay, helium is group 18, so it is atoms. Okay, cannot be divided anymore. Okay, next is the sodium chloride. Sodium chloride is a salt. So sodium is metal ions, then chloride is a non-metal ion. So it's ions. Okay, next is sugar. Sugar you see here, carbon non-metal, hydrogen non-metal, oxygen non-metal. So if all are non-metal, so they are molecules. Okay, cannot be atoms because atoms only one. Oh, this one is molecules. Okay, then urea, carbon, oxygen, ammonia, hydrogen, nitrogen, and hydrogen. So all are non-metal. So if non-metal with non-metal, so it's molecule. Okay, Then for the limestone, calcium metal, carbon carbonate. Okay, this one we look at as one. So carbonate ions. So metal and non-metal. So ions. Okay, lauric acid, carbon, hydrogen, oxygen. Correct? So all are non-metal, so it's a molecule. Okay, If you have any question you want to ask, you just put up your hand, Okay, next. Okay. This one, caffeine, caffeine, okay, is a drug actually. So you look into the structure. Okay. So it is a molecules. Okay, molecules. Then copper wire Cu. So you see only one atoms, so it's atoms. Okay, so far any question about this? If you are asked to recognize or to determine whether it is atoms, molecules, or ions, okay? Okay, next. Okay. Matter can be exist of three sets of matter, three physical sets. They are solid, liquid, and gas. Solid, liquid, and gas. Then change in the state of matter is caused by the heating or cooling. Okay, so during heating, the heat energy is absorbed to break or to overcome the force of attraction. For cooling, during cooling, heat energy is released during the bond formation. Okay, this one you can record down. Heat energy absorbed to overcome the attraction force. Okay, between particles. Okay, so absorb the heat energy. So during the cooling is heat release during the bond formation. Formation when cooling. Okay, when you form the products. Okay, form formation between particles. Okay. So number 10. Okay, this one. Okay, A, B, C, D, E. Okay. So now, okay, maybe I will call some names. Okay, A. So I want to check also lah, whether the student is paying attention or not. Okay, A. So from A is here, liquid to solid. Okay, liquid to solid. What is the process? And then what is the energy change? Okay, energy change. Okay, heat energy, whether it's absorbed or release heat. Okay, energy. Okay, first one A. 伤源 Liu Shangyuan.
Freezing.
Okay, freezing. Okay, the heat energy is
Release.
okay, release. Okay, heat energy is released. Okay, correct. Okay, freezing. Heat energy release. Okay, good. Shangyuan. Okay, next is B. B. Anastasia for B. Solid to liquid. Yeah, Anastasia. Solid to liquid. Okay, please pay attention, class. Okay, Dylan.
Yeah, teacher.
Yeah, what is your answer? B.
For the beer, melting,
Okay, melting. The heat energy is
absorb.
absorbed. Okay, correct. Okay, good, Dylan. Melting, absorb. Okay, C. C is liquid to gas. Liquid to gas. Okay. Catering. Catering. Okay, boiling or evaporation. Okay, heat energy is okay, absorb. Okay, heat energy is absorbed. Okay, correct. Your mic cannot function, huh? Catherine? Okay. Boiling or evaporation, huh? Okay, correct. Okay, next. D, reversely, gas to liquid. Gas to liquid. Okay, Chun Xiang.
Condensation.
Okay, good. Condensation. Heat energy is
Release.
okay, release. Okay, correct. Okay, now E. E is a gas to solid. Okay, gas to solid. Robin.
Deposition.
Deposition. Okay,
Heat release.
deposition. It is release. Okay, good. It is release. Like F. TT. Nefer. Nefertiti. Okay. lens ion. No. Okay. Sublimation. Heat energy is solid to gas. Solid change to gas. Absorb. Okay, good. Okay. Students, please pay attention. I will suddenly call your names. Okay. You need to pay attention. Okay. Now, 11. Okay. Now, drawing. Okay. So, solid arrangement of particles. Okay. So, just remember, no need to fill all the spaces. So, minimum is 3 times 3. This one is 3. This one also 3. Minimum. Then, no gaps. This one. No gaps. Here. Then, no overlapping. Okay. So in exam, I think first time of exam, I ask you to draw. So especially boys, you always very careless. When you draw very fast like this. Okay. If you draw like this, then it's wrong. This like the feather. Oh, cannot. Must be exactly one circle. No overlapping, no gaps. Some students will draw very fast like this. Okay, this one also wrong. So it must be draw properly. Then liquid and gas. Okay, Then energy content or energy content refer to the kinetic energy. Okay, so energy content, remember kinetic energy. So this one refer it to what? To movement of particles. If it can move freely, then it is very high. Okay, so gas, because there are a lot of spaces, so it can move freely, so very high. This one, no space for solid, no space for it to move, so it's very low energy content. Okay, this one higher than solid, but lower than gas. Okay, higher than solid state, but lower than gas state. The energy content. Okay, next is the attraction force between the particles. Okay, attraction force. And so you need to differentiate kinetic energy and attraction force. So attraction force, you just remember it. You need to see the distance. Distance between particles. Okay, if the distance is very close, then it is very strong. So you see, this one very close, right? Distance is very close, so it's very strong. Then this one distance is very far. Then this attraction is very weak. Okay, weak attraction. Okay. Then this one strong but less than weaker. Cannot be less. Okay, weaker than solid state. Okay. So the terms you use, okay, please take note on this. When we talk about the kinetic energy, okay, kinetic energy or energy content, we will use the word like high or low. Okay. Then when we talk about the attraction force, we use the word like strong or weak. Okay. Attraction force, you cannot use high or low. Okay. Attraction force, we use the correct terms, strong or weak. And next is a definition for melting point. Okay, melting point is a constant temperature. Okay, it's not the, you cannot say the point. It's a constant temperature where a substance change from solid to liquid at a, okay, change from solid to liquid at a specific pressure. Okay, huh? Okay, how about freezing point? Again, the same, is a constant temperature. Okay, constant temperature. Substance change from liquid to solid at the specific pressure. So when you define the melting point, boiling point, freezing point, you need to mention three things. Constant temperature, specific pressure, and then change from solid to liquid, liquid to gas, for example. So this is a correct definition. Okay. Very little things, but you need to write it, okay, correctly in exam. Okay. So normally weak student will write halfway lah. Okay, when define something, you will write like say a temperature or a point where solid change to liquid, like that. Okay, missing some of the important keywords, so the student cannot score or cannot get the marks. Okay, huh? Next is boiling point. Again, the same. Okay, 3 points. A constant temperature, change from liquid to gas at specific pressure. Okay, huh? This one, and this one. Okay. Okay, next, the following is the result of heating and cooling of naphthalene. Okay, you will see. Okay, we start from 60 degrees Celsius. So every 30 seconds intervals. So every 30 seconds, okay, we record one time the temperature. Okay, so you will see from 60 degrees Celsius is in solid, till 80. Okay, until 79 still solid, solid state. Okay, then at 80 degrees Celsius, you will see it will become constant, correct? Constant for a period of time, for remains for how long? 210 seconds to 360 seconds. Okay, so it remain constant. Okay, so remain constant. So meaning that this one fulfill the definition. You see, we go back to here. The melting point, correct, is a constant temperature, correct? Constant temperature here refer to 80 degrees Celsius. There a substance change from solid to liquid at a specific pressure. Specific pressure here refer to the room pressure. That is 1 atmospheric pressure. Okay, so this one remain constant, correct? So it's a melting point. After that, it melts. The temperature increase again until 90 degrees Celsius. Here only 89, so it turns to liquid state. Okay. Then for the freezing point, okay, cooling of naphthalene, so it drops from 0 seconds, 85, 84 until 81. Then start from 120 seconds, so remain constant again. Okay, for how long? Okay, for a few minutes, alright? Okay, but practically it will be longer than this now. This one is a theoretical. Okay, so this one remain constant, so this one is a freezing point. Okay, freezing point. Then after that it drops again until 62. So in the lab we won't get this beautiful data. Okay, normally it will be longer than that for the constant temperature. Okay, Okay, now based on the result, plot the graph, okay, against time for the heating of naphthalene and then cooling of naphthalene. On the graph, label the state of matter of naphthalene. Okay, then on the graph, determines the melting point and boiling point. Okay, sorry, melting point and the freezing point of naphthalene. Okay, so these three ABC, actually you have plotted in your workbook already. Okay, so this one you just refer back. Okay, now explain why the temperature. Okay, this one is a very popular question. Everybody, you should remember the reason. Okay, why the temperature become constant? Okay, constant during the melting point of during the melting of naphthalene. Okay, so remember the heat energy absorbed because it is a heating, right? Okay, heating process. So heat energy absorbed. Okay, for what? Used to overcome the attraction force between the particles. So this is a definition. Okay, the reason. Okay, so this is for heating. Okay, to explain it is the melting point. Melting point. Then for cooling, okay, cooling temperature remain constant. Okay, again, for this heat energy release, okay, lost to surrounding. Okay, heat energy release when the particles attract to each other to form a solid. Okay. Okay. Heat energy lost to surrounding or released to surrounding. Okay. This one loss or release. Okay. Release to surrounding is balance or is the same as heat energy released during the when the particles attract each other to form a solid. Okay. Meaning that this one it will form a bond, right? Bond formation. Okay, Okay, next is drawing. Drawing of the apparatus. Okay, this one have you draw? Okay, in drawing of the apparatus and so on, you just remember you just need to do the draw the 2D, 2 dimension. No need to draw the 3 dimension. So, okay, after you draw, okay, so this one actually can ignore this Bunsen burner. No need to draw the Bunsen burner. Okay, ignore this one. No need to draw Bunsen burner. Okay, we'll replace with an error. Just write heat. Okay, be like this. Save your time. Okay, use your time to do or to answer other questions. Okay, so whenever you need to draw the Bunsen burner, you just replace with the heat with an error. That is enough. Okay, and then some reminders here. Okay, this boiling tube, okay, cannot touch. Cannot touch this one, the bottom of the beaker. Okay, and then the level of this naphthalene must be lower than the water level. Okay, so these two normally common mistake by the students. Okay, then level water, and this is naphthalene. Okay, okay. Now, what is the relationship between the melting point and boiling point with the state of matter? Okay, so in gas form, okay, in the gas state, melting point and boiling point is less than room temperature 27 degrees Celsius. In the melting point, in liquid state, melting point is less than room temperature, but boiling point is more than room temperature. Okay, in the gas, melting point and boiling point is more than room temperature. Okay. Okay, next. Okay, so in an experiment, solid acetamide is heated until it melts. So the melting point of acetamide is the same as naphthalene. That is 80 degrees Celsius. So what is the state of matter at 80 degrees Celsius? Okay. So before it melts, okay, before it melts, it is solid state. So if the melting point is 80 degrees Celsius, so meaning that this is a melting point, correct? So in the melting point, what is the physical state? State of matter. This one, okay. Bernice Chang. What is the physical state? 80 degrees Celsius. That is the melting point. What is the physical state? Yes. What is the physical state? Okay, solid and liquid. Okay, good. Solid and liquid. Okay, good. Then melting point and boiling point is 200. Substance P is 250 degrees Celsius and 400. So what is the arrangement of particles at 320 degrees Celsius? Okay. So first you need to determine what is the state of matter, and then after that you determine the arrangement of particles. Okay, so this one I would like to ask Isaac Lee. Okay, what is the physical state first? Physical state?
Liquid.
Hmm?
Liquid.
Okay, liquid. Okay, correct. Then if liquid, then arrangement of particles. How are you going to explain? Write in sentence. Because just now we have drawn the arrangement of particles, right? If you write in sentence, how are we going to explain the arrangement? In the liquid state. Yeah, Ivan, how is the arrangement of particles at the liquid state? Hmm? Okay, next, Lucas, what is the arrangement? Lucas. Hmm?
The particle arrangement is an irregular and dense manner.
Repeat again. Irregular
Irregular and dense manner.
and dense manner.
Yeah.
Oh, okay. We have a simpler um, wording. Okay. Particles are closely packed. Okay. This one is given in the textbook. Closely packed like the solid. Okay. Packed closely, but not in orderly manner. Okay. We use this one. Oh. Closely packed, but not in orderly manner. For liquid. Liquid. Okay. If you use the dense wording of dense, that one is normally for overseas syllabus. Okay. Overseas one. So normally if you check the like ChatGPT, they will give some answers like this. Oh. Okay, next. This one is a clone SPM pattern. Okay. Now classify BW, XYZ according to the state of matter at room temperature. So here, room temperature is 27 degrees Celsius. Okay, 7 or 25 lah. 25. Okay. So what is the state of matter? So state of matter here would be solid, liquid, or gas. Later your answer should be like this. Which one is in the solid, in the liquid, and in the gas? Okay, So I show you one example. Let's say V. Yeah, V. Okay. If you are not sure how to determine the physical state, right? Okay, you draw a line like this. Okay. So you label melting point and boiling point. Okay. So before melting point, before it melts, the state will be okay. The state will be solid now. Okay. Then it start when after the melting point, it is in liquid form. Okay. Then after boiling point, it will be gas form. Correct? So this one is a cold things for you to label. Okay, now we look into V, substance V. Yeah, melting point is negative 179. negative 189. Then boiling point is negative 186. Okay, for B. Yeah. Now, at room temperature, okay, 27. So where is the location? Negative 189, negative 186. So 27. So it will be somewhere here. Correct? So 27. So the step will be gas. So this one you put in the gas form. So you put it here, gas B. Okay. So you do for another remaining 4. Okay. If you cannot see it directly, then you do like this. You put in one by one, X, W. Then see where is 27, the value. Then you will determine the physical state. Okay. So now I'll give you few minutes. You try to complete this table. Okay. So okay, I think you finished already. Okay, any questions so far? Anyone you cannot determine? Okay, don't be shy. If you really cannot, this one is a simple questions that you need to master. Okay, if this one cannot get it correct, then the difficult questions then is more difficult for you to get the marks. Okay, so you will see solid will be Y and Z. Okay. Liquid is W and X. Then gas only one, that is the B. Okay. Correct or not? Okay. Next, B. Draw the arrangement of particles for substance Y. Okay, Y. Yeah. At room condition. So Y it is solid state. Okay, solid state. So 3 times 3 lah. Again, 3 times 3. Okay. Next, name the process occur when substance Z is heated from room temperature to 200 degrees Celsius. Okay, so it start to melt because we see Z. Okay, so 115 is the melting point. Then boiling point is 445. So from room temperature, so 27 to 200. So melting point is 115. So at 200, so it's more than melting point. So it start to melt already. So it's a melting process. Okay, class? Next, sketch a graph of temperature against time when the substance W is cooled from room temperature to negative 10 degrees Celsius. So label the freezing point of the substance W. Okay. So for W, let's see. W. Okay, W negative 7. Melting, freezing, boiling is 59. Okay, so melting point is negative 7. Okay, so negative 7. Okay, melting point is 7 degrees Celsius. Melting point. So for your information, for the pure substance, melting point actually is the same as the freezing point. Okay, so this one must remember will be the same. Melting point same as the freezing point. Okay, then boiling point is 59 degrees Celsius. Okay, so it cool from room temperature to negative 10. Okay, so we know that the freezing point is negative 7. So because the question mentioned it's freeze from room temperature, so room temperature, so it's not yet reached the boiling point, so it start to drops. Okay, drops. Okay, then 27. Okay, start from room temperature 27. Then it drops until negative 7. Okay, negative 7. Okay, so negative 7 is the freezing point. Okay, so it become constant. Okay, constant. Then it drops to negative 10. Okay, because the question mentioned negative 10. Okay, then you need to mention the temperature with the unit. Okay, then X will be time with the unit seconds. Okay, so in the question not mention the unit for the time, so you must give one unit for it, whether it's seconds or minute. Okay, or minute. So normally we use the seconds. Okay. Some students will confuse that it's not given, so I don't put in the unit. So if you don't put the unit, then it'll be minus 1 mark already. No unit for it. Okay. So must put the unit for the time, seconds. Okay. So for the ending of this slot, okay, if we can finish earlier, then you can stop early, or we can stop early. So self-assessment. Okay, now you try to complete this. Then after that, we discuss the answer. Okay. Does minute count? Yes. Wei Xuan, Yes, if you put minute also can. Okay, now everybody you try, try to complete this. Okay, self-assessment. See you understand or you can catch up the whole slot 1. Hour also can, but it's too long. Oh, Luis. We seldom use the hour for the experiment because logically our time only 1 hour, right? If your experiment took very long, so it's not practical. Normally it's seconds or minute. Okay. Theoretical hour also counted now, counted, but it's too long. Oh. Okay, do first, do first. Give you 5 minutes. Huh? Okay, class, now you can fill in the attendance in the Google form. Okay, now we check. Okay, so YX2 undergoes sublimation process at negative 78 degrees Celsius. Okay, so sublimation is changed from solid to gas. Solid to gas at negative 78 degrees Celsius. So, what is a process? Okay, process change in the physical state. Sorry. Okay, so sublimation is changed from solid to gas. Solid to gas. Okay, now movement of the particles at room temperature. So particles move randomly and freely. Okay, and freely. Okay, this one you can mention it collide with each other is okay. Randomly and freely. Okay, in the gas, right? In the gas form. Then P is a substance that has a melting point is 51 and boiling point is 305 degrees Celsius. So sketch a graph. If temperature against time, again, when the P is heated from 30 to 90 degrees Celsius. So 51 is the melting point. Okay, so it becomes constant, but you need to mention the melting point also. So 30, you start to heat. Okay, then at 51, this one actually is the melting point. Okay, so it start to melt, so it become constant. Okay, constant. Then you heat again until 90 degrees Celsius. Okay, again, you see time, seconds. You use minute also can. Temperature, degrees Celsius. Okay. Now, when substance P is cooled down, the temperature decrease and become constant at one state and decrease again. Predict the constant time. Constant temperature, sorry. So constant temperature here refer to what? Refer to the freezing point. Okay, freezing point. So freezing point, same as the melting point. Okay, melting point. Okay, so that is 51, right? 51. Okay, now temperature. Explain why the temperature remain constant at the at that stage. Okay, so this one is melting or freezing. Is a freezing, right? Freezing point. So we use the definition for cooling process. Cooling process. Heat energy lost to surrounding, okay, or released to surrounding, is balanced by the heat energy released during the particles attract to each other. Okay, it's the one we discussed just now. Okay, loss or release now, release to the surrounding. Okay.